Lesson 3.3, we're going to expand what we did in the unit circle from last lesson, and we're going to focus on what you will spend most of your time doing on the unit circle, which is working with special right triangles. So that's the 45, 45, 90 special right triangle, which you'll recall is half of a square. And then there's the 30, 60, 90 special right triangle, which is half of a nice equilateral triangle. And so for this video, I think we're going to focus on the 45, 45, 90 group, just to keep it a little bit simpler. Recall that the 45, 45, 90 band or cluster is the pi over 4 in radians, followed by 3 pi over 4, 5 pi over 4, and 7 pi over 4. So I like to remember that as 1, 3, 5, 7, all pi over 4. That's my sort of way that I think of this. And that corresponds with 45 degrees, 135 degrees, 225 degrees, and 315. And for people who like to go to the gym, that's like the barbell just by itself. Barbell with two 45-pound plates, or one plate on each side, 2 plates on each side. So here we go. We'll draw a little bar. Here's our 1 plates. 225, we're now talking 2 plates, and then 315, that's our 3 plates. So that is one way you can remember your 45, 45, 90 band, and those angles, 1, 3, 5, 7, 45, 135, 225, 315. And we're just going to ignore the 30, 60, 90 for now. And so all of these angles share a common reference angle of pi over 4 or 45 degrees. And so if we draw our coordinate grid and we draw some of these angles in standard position, starting with 45 degrees or pi over 4, pi over 4 is in the first quadrant. If we drop an altitude here and build a little right triangle, this would be equivalent to if we had the 135 degrees, or this angle is 3 pi over 4. But when we drop our altitude, we end up with a triangle that has this little reference of 45 degrees, right? So these share the same reference angle. And we can repeat this process with 5 pi over 4. So starting here on the axis and coming all the way around, this would be an angle of 5 pi over 4. But our reference angle, when we drop our altitude to the x-axis, is still a 45-degree reference. And then again, with 7 pi over 4, we'd have that same thing happening. So that's a key vocabulary word. We say that these 4 angles, they all have the same reference angle of pi over 4 or 45 degrees. And that key term is reference angle, okay? And when we do some trig with these, you'll see that the reference angle and the angles that share it, they're all gonna have the same ratio. It'll just change whether it's positive or negative based on the quadrant. So they will have the, I'm gonna write that down, same trig ratios, but positive, negative often changes based on quadrant, where the first quadrant is plus plus, so x and y are both positive. Second quadrant is minus plus, x is negative, y is positive, minus minus, and plus minus. And so that's what's going to happen here. Okay, so let's go ahead and take a look here. So let me go to a unit circle. So we're going to draw a little circle here, and we'll say that it has radius of 1, because that is what the unit circle is. And we're going to look at the pi over 4 angle, so the reference angle of all the others. And let us say, so I'll draw my angle in standard position. Here's my angle of pi over 4, or 45 degrees. And I want to know, where does this point intersect the unit circle? or where does this angle intersect the unit circle? What xy coordinates? And recall from our last video that we said, well, that would mean that sine of pi over 4, based on how our unit circle works, would be simply the y coordinate, and cosine of pi over 4 would be the x coordinate. If you want a refresher on that, go back to the last video. But we sort of determined that that's what one of these really powerful things are, or is. So if we want to think about this, we can drop our altitude, build our triangle, and the pi over 4, or 45 degrees, is our special right triangle. So we're going to use the ratios of our special right triangle. And we know that in a special right triangle that is a 45, 45, 90, or pi over 4, so on, we have side lengths in a ratio of, I'm going to use a root 2, a, and a. So two side lengths are identical, and the hypotenuse then is that times root 2. But because this is the unit circle, our hypotenuse is 1. So a root 2 must equal 1. So we're going to say a square root 2 equals 1. I want to solve for a to actually get my side lengths because those correspond to my x and y coordinates. So I will get a equals 1 divided by square root 2. Rationalizing, I get a equals square root 2 over 2. That is super important. So this is something that you ought to memorize, that square root 2 over 2. Because for the 45, 45, 90 triangle band, or the pi over 4, 3 pi over 4, so on, all of the sine and cosine ratios end up being root 2 over 2, essentially. And some are positive, some are negative. But because this is a 45, 45, 90, this is root 2 over 2, this is root 2 over 2, and this is 1, which corresponds directly to our coordinate plane here, root 2 over 2, root 2 over 2. That makes my x root 2 over 2 and my y root 2 over 2. I have this nice isosceles right triangle here. So putting the ratios together, I'm going to say that sine of pi over 4 is equal to square root 2 over 2. That is the ratio that also ends up being the y coordinate on the unit circle. Cosine of pi over 4 is also equal to square root 2 over 2. And then the tangent ratio of pi over 4 is going to be root 2 over 2 over root 2 over 2. It ends up being y over x, or just 1. So this is a really important set right here, particularly the root 2 over 2. This is something that I would say you want to memorize. The root 2 over 2 is a number you want to have in your head, and you want to associate that with 45, 45, 90s, because that's the coordinates when the hypotenuse is 1, that makes the side lengths root 2 over 2, and that makes sine and cosine of pi over 4 root 2 over 2. Okay, and that's really the most important piece, because when we talk about this term of reference angle for all 4 of these, they'll have the same trig ratios, but the positive and negative changes based on the quadrant. And so let's go ahead and take a look and see how that works. So let's block this off. I'm going to draw another unit circle. And let's do a green. And this time we're going to do an angle of 3 pi over 4. So that lands us in quadrant 2. Here's my angle of 3 pi over 4. Now my reference angle for 3 pi over 4 is pi over 4. But I could ignore that for a moment, and I can just say, okay, I want to find my xy coordinates, realizing that sine of 3 pi over 4 is just going to be the y coordinate, and cosine of 3 pi over 4 is going to be the x coordinate. And so if I can find these, I'll be able to know the ratios, which is the whole power of this unit circle. So I'm going to drop my altitude, 90 degrees. This would be 45 degrees, or pi over 4, which is why we say that's the reference angle. And I'm even going to label that as the reference angle. And so if I consider a 45, 45, 90 triangle, well, we just did it for the same triangle. This one's just facing the other way, but we said the hypotenuse is 1, or a root 2, and the side lengths were a and a, but we said when we do that, we get square root 2 over 2 and square root 2 over 2. So that's the same thing. It's the same triangle. It's just facing to the left. And so facing to the left means that, in fact, this one here, the x coordinate, is going to be negative. So my x side length is going to be negative root 2 over 2. My y side length and my y coordinate will be positive root 2 over 2, corresponding to the quadrant 2 where I have negative x, positive y. And so sine of 3 pi over 4 is going to be still positive root 2 over 2, same as the reference angle. But cosine of 3 pi over 4 is going to be negative square root 2 over 2. And then tangent of 3 pi over 4 is going to just be negative 1. So we get this same set of ratios, but depending on the quadrant that our actual angle is in, we get different negatives and positives. So a good question would be, say for example, what if I have an angle in standard position with a reference angle of pi over 4, and sine and cosine are negative, but tan is positive, okay? And let's add in, I'm talking about some angle theta, cosine theta and sine theta are negative, and tan of theta is positive, because technically we're talking about functions on an angle. And so what we'd have to realize is sine and cosine are negative. This is almost like saying x and y, or y and x are negative, but y over x is positive, which makes sense. Negative divided by negative gives us positive. So if we think about our grid here, that can only happen in quadrant 3. That's the only time I'm going to have a negative sine and a negative cosine ratio. So I must have some angle in quadrant 3 that has a reference angle of pi over 4, or 45 degrees, and based on the set of angles, that must be 5 pi over 4 radians. So theta must equal 5 pi over 4. So this is a way that we can reason through that. And then based on that, I can just get my ratios. I could say sine of 5 pi over 4 is going to be root 2 over 2, except it's negative because we are in quadrant 3. The y coordinate here is going to be negative. So I have negative root 2 over 2. Cosine of the angle 5 pi over 4 is going to be negative root 2 over 2. And tangent of 5 pi over 4 is going to be positive 1, simply because negative divided by negative is positive. My xy coordinates where this angle intersects the unit circle is going to be negative root 2 over 2, comma, positive root 2 over 2. And that's really the main idea behind all of this. And so the key thing is that this set of angles can basically be memorized only by knowing that they share this 45, 45, 90. All I really have to know to work all this out is that the 45, 45, 90 angles are in the ratio of a to a root 2, or two side lengths are equal, and then the hypotenuse is root 2 times the side length. Everything else can be built from there. But it's really, if you can just memorize this, root 2 over 2 and root 2 over 2 for pi over 4s, then you've got all 4 of these things memorized, and you're well on your way to having the special right triangles of the unit circle memorized. So just to summarize here, if we just look at this as memorization of the unit circle, or being very fluent and being able to do these kind of things on the unit circle, let's pretend this is the unit circle. Well, that means there she goes. All right. So here we go. Say this is pi over 4 is my radians, and my x comma y is going to be root 2 over 2 comma root 2 over 2. Then if I have my angle corresponds with 3 pi over 4, my x and y coordinates are going to be negative root 2 over 2 and negative x in quadrant 2, positive root 2 over 2, because it's a positive y in this quadrant. Then if I have my angle 5 pi over 4, I'm going to have negative root 2 over 2, comma, negative root 2 over 2, because we are negative, negative in quadrant 3. Both x and y is negative. And then finally, in quadrant 4, x is positive, root 2 over 2, and y is negative, negative root 2 over 2. And so simply by knowing this point, or the trig functions on this one angle here, pi over 4, I'm able to really fill in everything else simply by changing the signs to correspond to the quadrant. And the interesting thing here is this would apply no matter what. There's nothing special about pi over 4. Like, let's pretend I knew that some angle theta here, some reference angle of theta, has an xy coordinate of, let's just call it a comma b. Let's pretend I don't really know what it is. Well, then the symmetry would tell me that I have some other angle with a reference of theta out in this quadrant, and the coordinates would be negative a comma b. So my x coordinate becomes negative, my y stays positive. Then in quadrant 3, I would have another angle with that same reference angle, like a theta in here. This would be negative a comma negative b. And then in quadrant 4, I would have positive a, negative b. So this is generalizing and saying that for any reference angle theta with some coordinates, and remember those coordinates are literally sine theta is b, cosine theta is a. So my ratios are going to apply to these other angles that share the reference angle. So that's sort of the main idea of how we can work with the unit circle, how all this stuff from quadrant 1 is going to really carry us over to the other quadrants. All of this is the reference quadrant, and then the other quadrants sort of mirror that with different signs. And then most of what we do, and especially really all of what we do without a calculator, is based on the special right triangles. So in this video, we looked at 45, 45, 90. I think in the next one, we'll take a peek at 30, 60, 90. But go ahead and memorize these, and you'll be well on your way to working with the unit circle without a calculator.